Good morning, namaskar and welcome to the course once again. In the previous lecture, we discussed bidding models. In particular, we discussed Friedman model and Gates model. These models were discussed for two situations. In the first case, we said that the identity of competitors are known and their numbers are also known. In the second case, we said that identity of competitors are not known, but their numbers are known. For these two situations, we discussed the formulas given by both Friedman as well as Gates. We said that Friedman's model is giving us slightly lower value of markup, as this is based on power model. So, individual probability values are multiplied to get you the winning percentage. So, in that sense, it is slightly on a pessimistic manner. On the other hand, Gates model, you find it is very close to the real value, and in fact, these two models were subjected to a lot of scrutiny, and according to one researcher, it was said that Friedman model is best suited when the difference in bid price is primarily on account of the markup. Now, in this particular lecture, we are going to discuss how to determine the optimal markup level. That means, we are interested in finding that optimal markup at which the markup amount is maximum. You will find that when your probability values are, you will find that when your markup percentage is low, your probability of winning against that competitor is quite high. So, your expected markup is still on a lower side. When you go on increasing this, you will find the markup amount increases. You will find a point at which there would be a drop in markup amount. So, we are looking at that particular markup percentage at which the expected markup amount is the maximum. Now, we are going to do this in a step by step systematic manner. So, we will first discuss all the steps and then we will give you one small example and we will illustrate how to determine the optimal markup percentage. So, let us move to the various steps. In the first step, what I do is I take very small value of markup percentage, say it could be 1%, it could be 1%. Now, for this 1% markup, what I do is I calculate my markup amount. How do I calculate the markup amount? It would be done like this. Say for example, your total cost is 100, right. You are saying, okay, I am applying 1% of total cost as markup. Let us say you are saying markup as 1% of total cost. So, this is going to be 1% of 100, which is 1. So, what is your markup amount? Markup amount is basically 1 rupee. Now, how do we calculate the expected value of a markup amount? Expected value, suppose the probability of beating this competitor at 1% is, let us say probability, let us say 0.9. So, my expected value of markup is going to be 0.9 into 1, which is 0.9. Now, what I do? I let us say increase the markup from 1% to 2%. So, let us say this is 2% of total cost. So, as before, now this markup amount becomes 2 rupees. Now, let us say when you increase this markup percentage, your probability has slightly dropped. So, it could be let us say 0.85, suppose. So, your markup amount will become now 0.85 into 2, which is 1.7. So, you found that when you quoted at 1%, your likely markup amount was 0.9. When you are quoting at 2%, it is likely to go up to 1.7. Likewise, you will find that initially there would be an increase in the markup amount, but subsequently you will find that this value will come down. So, we are trying to plot this curve and we are trying to locate the exact markup. Now, this exercise we are going to do it for both the models. We are going to do it separately for Friedman's model, we are going to do it separately for Gates model. In the previous lecture, if you remember, we said that the modern trend is to take the average value of the markup computed from both the models. So, for the first case, I am going to find out the optimal markup amount from Friedman's model. Likewise, I am going to do this for Gates model, and then at the end I am going to take the average, and that is what I am going to apply on my bid, right. So, coming to the next steps, now you know how to calculate the markup amount. I have already explained you. If you want to use the formula, you can use it. Markup amount is markup percentage upon 100 multiplied by TC. So, I gave you the example of 100 rupees total cost, and markup I applied was 2 by 100. So, total markup amount was 2 rupees. So, this is how we calculated for our 100 rupees total cost example. The third step, I can calculate the probability to beat different competitors, say x1, x2, x3, xn from the past history of competitors as explained in the previous lecture. I will show you in this class also. Then using Friedman's model, I am going to find out the probability to win at markup level m. How do I do it? It is calculated like this: expected markup amount is markup amount for a given markup percent m multiplied by probability of winning at the markup percent m. You will see this how it is done. Now, having done this, I increase the markup from m to m plus 1 now, and the expected value of markup amount is calculated again as in step 5. Then based on the above values of markup percent and the expected markup amount, a curve is plotted. So, you will find a curve will be plotted. So, this curve will be plotted between which two variables? One is your markup percentage. So, on this axis you have markup percentage 1%, 2%, 3%, n% and so on, and on this axis you will have expected markup amount. So, money in terms of rupees or dollar would be on this axis. Now, having done this, we can either read from the above plot what is the value of optimum markup percent, or else you can do all these calculation in spreadsheets like Excel, and then you can directly get what is the optimal markup percent. Let this be M1. Now, all these 8 steps what I told you just now, we do it for Gates model also. Gates model is going to give you a different markup percentage because the formulas that we are going to use here is different, and let us say the optimal markup that we get from this exercise, we are getting it as let us say M2. So, M1 I got it from Friedman's application, M2 I get it from Gates application. Now, as I told you in the previous lecture, we will add it up. So, M1 plus M2 by 2, and that is what we will apply in my total cost to submit a particular bid. So, this is the various steps which we need to follow. Now, we try to explain these steps with the help of one small example. Now, in the example I am given the histogram, which is nothing but the compilation of past behavior of 15 bids. So, the number of bids is 15 of a typical contractor against you as a contractor. So, you are the contractor and you have got the past data of 15 bids against a typical contractor. Now, in the histogram, B by TC ratio indicates competitor's bid price to your total estimated cost. So, bid price divided by total estimated cost. Now, the question is, based on the given behavior, what is the markup value that this competitor uses on average? This is what you have to find it out, mean value of the markup percent. What is the probability of winning against this competitor if you use a markup of 12%. So, this is the other question. Now, the next question is, in a new project with an estimated cost of this much, what is your optimal markup strategy against 4 typical competitors? So, it is saying that you are quoting for a project which is 5 crore project estimated cost. How much will be the markup percentage that you will apply if you are quoting against 4 typical competitors? Typical competitors are showing a histogram like this of their bidding behavior. So, we are going to do this both using Friedman's model, Gates model, and we are also told what is the expected markup amount at the optimal markup and what would be your suggested markup level. So, as you know, the trend is you calculate the markup using Friedman's model also, using Gates model also, and then you take the average to get the percentage. What is done here is we have been given a set of past data in which you as a contractor, your cost and the competitor's bid price details are given. You are told on an average what is the markup percentage that this typical competitor is applying. Next question is, what is the probability of beating this competitor if you are quoting at, let us say, 12% margin in your next project. And the third question is, in a project which you are bidding right now, which estimated cost is 5 crores, what will be your markup if you are using Friedman's model, what will be your markup if you are using Gates model, and what would be your strategy. So, these are the questions. Now, if you look at the histogram, this is how it looks. So, this axis is giving you B by TC. So, your competitor's bid price, typical competitor's bid price to your total cost. So, you find that in one project, the typical competitor quoted 2% below your total cost, 0.98. This is what 0.98 B by TC mean. In one project again, it was quoted at no profit, no loss. B by TC 1 means the typical competitor did not apply any profit margin on your total cost. In 2 projects, they quoted 2% higher than your cost. In 2 projects, 4% higher than your cost. In 1 project, 6% higher than your cost. In 4 projects, 8% higher than your cost. In 1 project, 12% higher than your cost. In 2 projects, 16% higher than your cost, and in 1 project again 20% higher than cost, higher than your total cost. Here it is 0% and here it is minus 2%. So, in terms of percentage, now you know for these 15 projects. So, the first question is, what is the mean for this? That is not a difficult thing to calculate. You can do it in a normal manner. You calculate the mean. So, that gives you mean value. You have to also calculate the sigma. So, sigma you will calculate it first by calculating sigma square and then by taking under root of that to give you the standard deviation. So, I have calculated this and I am finding that the mean value is coming to be 1.07467 and standard deviation is coming to be 0.0630. These two values you can cross check it. So, I find that my mean value for this particular example is coming to be 1.07467 and sigma, if you calculate, it is coming to be 0.0630. So, this first part of the answer. So, mean value and standard deviation have been calculated, and from where I am able to calculate this? From these distributions. So, I am given these distributions. So, I take the average of those percentages and I am getting this, and using the formula for variance I am able to calculate the variance and thereafter the standard deviation. Now, the next question is, what would be the probability of beating this competitor if you are bidding at 12% markup. So, I can calculate the value of z. Z you know is x minus mu upon sigma. Now, at 12% x becomes 1.12. Mean is what? I have already calculated 1.07467 and sigma is 0.0630. So, I am getting z value as 0.76424. So, this is my z value. Now, once you have got this z value, I can calculate the probability of winning against this competitor at 12% markup. For this, you have to look at the normal distribution table corresponding to this value of z. So, if you see here is the value, and in this table we can locate the z value corresponding to 0.76. So, 0.7 is this row, and you can find the value corresponding to 0.76. This is coming out to be 0.2764, right. So, from here we can calculate the probability of winning against this competitor at 12% markup. Now, just to give you an idea of this normal distribution, it is like this, and you have already calculated the mean value as 1.0764. So, that means if you quote above this value, you have a less than 50% chance of beating this particular bidder. If you are below this, you have about 50% chance of beating this bidder. Now, we are calculating it for 1.12. So, 1.12 will be somewhere here. So, what is the probability of beating this competitor if you are quoting above at 1.12? So, this value we are supposed to be finding, and that way if you calculate, we are getting the probability of winning as 0.2356, rather 0.23576. This you can cross check, this is roughly about 23.5%. So, that means if you are quoting at 12%, the probability that you will beat your competitor is 23.5% only, right. You can see here, this is how you can calculate. 1.0764 was the mean value here, and I am looking for a probability corresponding to x of 1.12. So, it would be lesser than 50%. So, 23.5% is the value I got to beat this competitor at 12% markup. Now, this was specific to 12%. Now, as far as the third part of the problem is concerned, we can go straight to the table which I have prepared here. Now, for this table what I have done is, as I told you in step 1, you have to take smaller percentage of markup to start with, and from there only you can calculate the expected markup value. So, let us say if the markup percentage is 0%, let us say I am bidding at no profit, no loss. So, in that case my x is going to be 1. So, z will be minus 1.19. How? This z becomes x minus mu. So, x is 1, mu is 1.07 and standard deviation was 0.06. So, if you calculate this, you will get in minus, and it would be minus 1.19. Now, I can read out the probability from the standard normal table, and it is coming to 0.11799, right. So, that means the probability from this table, this particular table you can find it in my book, Construction Project Management Theory and Practice, and this table the figure would look something like this. The values given are from this point onwards. So, for a z value equal to z, we are measuring and giving you these values in this particular table. Some of the other books, they will be giving you cumulative values. So, the value would be from minus infinity. So, if you are using this particular table, you will have to add 0.5 also. This is not added in my table, you will have to add 0.5 because the area, half of this area is 0.5 and half of this area is remaining 0.5 like this. This is 0.5 and this also is 0.5. So, any value that you read it from this book, you will have to add 0.5 there. So, for example, corresponding to Z of minus 1.19, you are getting probability value of 0.11799, and so the actual probability value would be 0.88201. This you have to read it from the book and then you will have to derive this probability of winning. So, this is at 0% markup. So, what will be the probability of winning the bid against 4 typical bidders? This is only one. Now, in the problem it is given that there are 4 typical competitors. So, I am using the Friedman model, I am multiplying P typical with P typical with P typical with P typical 4 times. So, if you multiply 0.88201 into 0.88201 into 0.88201 into 0.88201, you are going to get this value. So, this is the final probability of winning the bid with 4 typical competitors, right. Now, this probability I am multiplying with the markup amount. Remember, we are quoting at 0% markup. So, that means my markup amount is 0. So, when I am multiplying 0 with this 0.6052, I am getting 0 only. Now, I do this calculation at 1%. At 1%, my x becomes 1.01. So, z becomes minus 1.03. From my table, I am reading 0.15235. So, probability of winning against this bidder, only one bidder is 0.184765. So, when I multiply this 4 times, I am getting 0.5162. So, this value I am multiplying it with 1% of 5 crores. So, 1% of 5 crore multiplied by 0.5162, I am getting 2,58,123. So, you can see from 0 it has increased to 258,000. Then I do this calculation at 2%, probability of winning against 4 bidders is 0.4246. Now, what is this value? This is 0.4246 multiplied by 2% of 5 crores. So, how we are getting this? This value multiplied by 2% of 5 crores. I am getting 424. Then I do this calculation at 3%. I am getting the probability as 0.3351. So, you can see the probability is going on reducing because I am going on increasing the markup percentage, but my expected value is increasing in the beginning. How I am getting? This value of 502 lakhs, this is 0.3351 multiplied by 3% of 5 crores. I am getting 502. Likewise, when you do this at 4%, probability has further come down 0.2526. When you multiply this with 4% of 5 crore, we are getting 4% of 5 crore, we are getting 505. So, you find that initially the values are increasing and then they have come down. If you try to plot this, you will get a graph something like this. So, you can see at 3% it was somewhere here, at 4% it was somewhere here. Now, once you know that there is a drop from here onwards, you can increase the decimal places. Say right now you have taken the markup percentage at 3, now you can take maybe 3.1, 3.2, 3.3 and do the calculations again till you find there is an increase and then there is a drop. So, let us say between 3.3, 3.4, 3.5, 3.6, you observe that values have dropped. So, then you take the further decimal places, maybe you can keep 3.51, 3.52, 3.53 and so on. So, you go on doing like this. If you do this particular example in Excel, you will find that you are able to get the maximum markup amount against a markup percentage of 3.53. So, we are getting the maximum markup amount corresponding to a value of 3.53%. This you can do it as an exercise in Excel sheet. Now, the same calculation what I have told you just now, we have to repeat it for Gates model. So, what I do? I again start with 0%. So, my x becomes 1. So, my z as before becomes minus 1.19. This value will also remain unchanged. So, my probability of winning the bid with only one typical bidder, this will remain unchanged. Now, there would be change here. Final probability of winning the bid with 4 typical bidders, I am going to use this formula, which is given by the Gates, 1 upon n multiplied by 1 minus p typical by p typical plus 1. So, if you use this formula and if you use this p value as 0.88201, I will tell you how you have to use this. So, you will do it something like this. P just now you calculated it to be 0.88201. So, the probability of winning against 4 bidders will be given by 1 upon n into 1 minus p upon p plus 1. So, if you go on doing this, 1 upon n in this case is 4, 1 minus 0.88201 upon 0.88201 plus 1, you will get 0.6514. This is what is shown in this particular slide, 0.6514. Now, when you multiply this with 0% of 5 crore, you will get 0. Then you do the same calculation at 1%. For 1%, the probability remains unchanged, 0.847, but the final probability of winning the bid with 4 typical bidders will be changed if you are using Gates model. Now, this value multiplied by 1% of 5 crore, you are getting 290,874. So, it has increased from 0. You do this calculation for 2%, you are getting this value, 3% this value, 4% this value. Now, you can plot this also as we have done in the previous case, and you find that the graph would be something like this at 5% somewhere here, 6% somewhere here. So, peak is in between 5 and 6%. So, you can go on changing. So, 5.1, 5.2, 5.3 percentage we can take. Then subsequently, I can use 2 decimal places. So, if you do this exercise in the same manner in which you did it for Friedman model, you will find the optimal markup is coming against a markup percentage of 5.5%. So, what we discussed here is corresponding to Friedman model, I am getting the peak at 3.53%, corresponding to Gates model, I am getting the peak at 5.50%. Now, in the previous lecture, I already told you that the modern trend is to derive the markup percentage using both the models and take the average. So, when I take the average of 3.53 and 5.5, you will get a value of 4.515%, and this is what I am going to apply in this particular project. So, this would be my strategy to apply for the next project. So, in this particular lecture, if I have to summarize, we discussed all the 10 steps that we need to carry out in order to determine my optimal markup. So, what I do? I start with 0% markup, I find the expected value of markup, I increase the markup from 0 to 1, I again find out the expected markup, then I do this calculation at 2%, 3%, 4% till the time I get the markup percent at which I am getting the maximum markup amount. So, this I note it down for Friedman's model. The same step I carry on with Gates model, there also I get that particular markup percentage at which I am getting the maximum markup amount. I take the average of these 2 markup percentages, and that is what I apply in the new project. So, this is all about determining bidding model that we had to discuss in this lecture. So, this completes our discussion on bidding process and our strategies to determine the bid price. In the next class, we have to start accounting, which is the major part of this particular course, and we will have different lectures pertaining to accounting part. So, till then, if you want, you can refer to these reference books. Thank you very much and see you some other time. Thank you.